Hello, this is Mr. Henry, and welcome to lesson 6.3. Today we're going to talk about solving multi-step inequalities. So the essential question says, how do I solve multi-step inequalities? Let's go ahead and get the goofs done and move on to the lesson. So here to solve this, we would divide by 2 on both sides. These would cancel out. R would be less than a negative 4. And I have no clue why they changed the direction of that inequality. You did not divide by a negative, you divided by positive 2. So that would mean that now we should have the arrow going the other way, and all these numbers down here are going to be wrong because they should be negative, and you can't just throw a negative in front. -5, -6, that would be correct. Alright, number 2, let's see, we would times by 3 on both sides. These cancel out. T is greater than 24. Okay, so everything's good so far, up to here. Now, the variable's on the wrong side, so I would flip-flop everything. So t here, 24 there, and change the direction of the inequality. Boo. They have this correct, they have their hollow dot correct, but the arrow is facing the wrong way. Now we're correct. Make sure you change the direction of the inequality and make sure you put the variable on the correct side when you graph. Number 3, it says negative m is less than negative 23. Okay, so this is a negative 1m. So you would divide both sides by negative 1 to get rid of that m, or to get rid of the negative there. And when you divide both sides by a negative, you have to change the direction of the inequality. So unfortunately, this one's not correct because they did not change the direction of the inequality, and that means their arrow is going to be facing the wrong way. We should have that. And let's check out their number line down here. These are wrong. Negative 24 is not bigger than negative 23. It's actually smaller. So we should have negative 23, negative 22, negative 21, negative 24, and negative 25, like that. Alright. Same vocab, inequality. We're not going to put it up again. We've seen it 1,000 times. It's where the two sides are not exactly equal. What I would like you to do, though, is fill in the circle type portion of your vocabulary box. Go ahead, pause the video, take 30 seconds, and fill it out. Okay, so you should have done it by now, hopefully. And you've got hollow dots and solid dots. Hollow dots come from if you have a less than or greater than. And solid dots come if you have a less than or equal to, or greater than or equal to. Now, one thing I would like to remind you of, since it's been a while, but we've been doing equation stuff for a while now, but I want to remind you of the 5 steps of solving an equation, because today we're talking about multi-step inequalities, so you got to make sure you're doing these multiple steps in the correct order. So things like the steps 1, 2, 3, 4, 5 that we had before, the first thing you get rid of is parentheses. Then, on each side, you combine like terms. Then, if you have the same variable on both sides of the problem, get rid of the one on the right. So get rid of right variable. I'm just abbreviating because I don't have space here. After you did that, then we're down to the normal equations where you get rid of the multiply or get rid of the add and subtract. And then finally get rid of multiplies and divides. Okay, so this is just a refresher. We did this way back in Chapter 3, and if you need to go back in Chapter 3 and watch a lesson on multiple step solving equations, do that if you need a refresher. But we're going to get into it. So here we're going to solve these multi-step inequalities. So I have here a two-step. I can see it's two-step. To solve this guy, we do not have any parentheses. We do not have any like terms on either side. We do not have the same variable on both sides of the problem. So we're down to step 4. We get rid of the add and subtract. Minus 8. 17 minus 8 is 9. Then we have to get rid of the multiply and divide. So we're going to divide by 3 on both sides, and w is greater than 3. Now we just take that and we graph it. The rest of the problem is the same. So we're really not learning anything new here. We're just combining a couple different things we've known into one type of problem. We're combining the multi-step inequalities, or the multiple step equations, where you follow those 5 steps in order, and then inequality stuff with the graphing and the number line and this hollow dot or solid dot and which direction you shade. That's all. Letter B. Well, to get rid of this negative 19 or this minus 19, we need to add 19 to both sides. These cancel out. We get 8m is less than or equal to 24. And then the opposite of times by 8 is divide by 8. These cancel. M is less than or equal to 3 again. All right. So 3, 4, 5, 2, 1. Solid dot this time. Solid dot at 3. And we would shade to the left. There's letter B. There are 2 problems I'd like you to try. These are letters C and D. Please go ahead, pause the video, do them on your own. When you're ready to get a little help or you're ready to check over them, hit play and we will go through them together. Alright, so let's see how you did. My guess is letter C here. If you made a little mistake, it's probably in letter C. You might have tried to add 31 to both sides because you saw, oh, z minus 31, but that's wrong. This 31 is positive, so you'd have to get rid of it using a minus. So you'd minus 31 to get rid of them. 43 minus 31 is 12. And over here, you're still left with a negative 2z. It is a negative 2. Then we have to divide both sides by negative 2. And I'm going to run out of space, so I'm going to start hopping over here. When you divide by a negative 2, you have to change the direction of the inequality. So this is going to be, my z still over here. This is going to be a negative 6. But this inequality has to change. So it goes from a greater than to a less than because I divided by a negative 2. Now, you're looking at that, you're going, my variable's on the wrong side, so we have to switch the variable to the other side and change the direction of the inequality along the way. So in this problem, we did have to switch the inequality twice. Once because we divided by a negative, and once because our variable was on the wrong side. Now we graph negative 6, negative 5, negative 4, negative 7, negative 8. Hollow dot at negative 6, make it a little bigger. How about we just try the whole darn thing again, huh? There we go. And we're shading to the right. Greater than to the right, all that good stuff. So that problem was a little bit harder. If you made a mistake, hopefully you understand where you made the mistake. Letter D you're going to find is a bit easier. So we're going to start by minus 9. We get 5d is greater than or equal to 35. 5, I want to say. Yep. And then we divide by 5 on both sides, and d is greater than or equal to 7. See, these canceled out, those canceled out. Yep. And we got 7, so then 7 and 8 and 9 and 6 and 5. We use a solid dot at 7. And then we shade to the right. And that's the answer for letter D. Now, we're just progressing on with this, solving multiple steps. Here we have problems where we have to combine like terms. And I really don't like this yet because actually this is not combining like terms yet. These are examples of when you have the same variable on both sides. So think about our 5 steps. We don't have any parentheses. Second step is combine like terms. Well, there's nothing over here that I can combine together. I can't add or subtract that. Ooh, I was trying to grab the blue line. There's nothing over here I can add or subtract together. So that combining like terms is kind of mislabeled. This is an example of when you have the same variable on both sides. I have an r on one side and an r on the other side. So the rule we said was we're going to get rid of the variable on the right. We're going to get rid of this guy. So how do we get rid of this negative 7r? Well, the opposite of a negative 7r is to plus 7r. These cancel out. I'm going to need more space than I have here. We're going to get, well, this negative 6 plus 7 gives us 1r. 1r. Plus 3 is greater than or equal to 9. And then we minus 3 on both sides, and r is greater than or equal to 6. And we put 6 in the middle, and 7, and 8, and 5, and 4, and solid dot, because it has the or equal to line. And we're going to shade to the right. Letter B. I do not have any parentheses. I cannot actually combine anything on either side of the problem. Nothing adds there. Nothing can add or subtract there. So do I have the same variable on both sides? And the answer is yes. So let's get rid of the one on the right. So we're going to get rid of this guy. So we're going to minus 3y. He cancels out. Minus 3y. Oh, darn. This guy cancels out too. Now we're left with negative 7 is greater than negative 7. Okay. Is negative 7 greater than negative 7? No, it's not. It's equal to. It's not greater than. So this problem has no solution. Do you remember having problems with no solution earlier, where after the variables canceled out, you get something that's like nonsense, like 3 is equal to 8. Well, no, 3 is not equal to 8. So we had no solution. Well, the same thing's true here, except now with these inequalities, you just got to pay attention to them. Is negative 7 bigger than negative 7? No. So this is no solution. There's nothing you could plug in for y that will make the left side bigger than the right side. It's always going to be identical. That's the kind of stuff that you can get anytime you have variables on both sides of the problem. It's always possible to have where the variables cancel out and you get no solution, or all real numbers, or just a single answer like we've had before. Please try letters C and D right now. And I can tell you right now, both of these problems will have a solution. You will not get no solution for either of them. go ahead and solve the problems right now. Okay, so hopefully you're done, and let's see how you did. You would start by getting rid of this 3t. So you'd minus 3t. These cancel out. That gives you minus 5t here. And write down the rest of the problem. You need to get rid of this negative 7 out front, because we're getting rid of the adds and subtracts, and the variable has this negative 7, so you add 7. These cancel out, so we get negative 5t is greater than 15. I'm going to extend and draw down a little bit. There we go. Just give me lots of space. Then we need to get rid of this multiply by negative 5, so we divide by negative 5, and I hope you made the connection, because when you divided by a negative, you changed the direction of the inequality. If not, go back and fix it. Now you get your negative 3 and smaller, I'm sorry, bigger and bigger, and smaller and smaller. You put a hollow dot at negative 3, and you shade it to the right. That shade got a little sloppy, but that's okay. Letter D. Get rid of this 5d, so minus 5d, cancel, minus 5d. Gives you a negative 7d. Minus 4 is greater than or equal to 10, and that stuff's all gone. Okay? Get rid of the add and subtract, so we're going to add 4 to both sides. These cancel. We get negative 7d is less than or equal to 14. Divide both sides by negative 7, because that's how you get rid of a multiply by negative 7. And I don't know if you heard that. We're dividing by a negative. So you switch the direction of the inequality. Get negative 2. Negative 2, negative 1, 0, negative 3, negative 4. We use a solid dot at negative 2 because we have this or equal to line. We use a solid dot at negative 2, and we shade to the right. And we are done. Hopefully you had some success. You might have tripped up a little bit at a step or two in there, but we're still remembering, we're still getting. I'd like you to try these 3 problems from the textbook. These are numbers 4, 5, and 6. Pause the video, do them on your own. When you're ready to continue, hit play, and we will go through them together. Okay, so hopefully you had time to do, so let's get to it. I don't have any parentheses. Yeah, get rid of this 3x on the left-hand side, because I've got an x on both sides. So minus 3x here, these cancel, minus 3x there. So that gives us 2x minus 12 is less than or equal to negative 4. All right, so let's solve. So now we're going to add 12 to both sides. These cancel. 2x is less than or equal to 8. The opposite of times by 2 is divide by 2. Divide by 2. These cancel. X is less than or equal to... This divide by 2 is a little low. 8 divided by 2 is 4. So we put 4, getting bigger, getting bigger, getting smaller, solid dot at 4, because we have the or equal to line, and we shade to the left, because we have less than, x is less than 4. We're using the arrowhead trick, and it looks like an arrowhead pointing that way. Number 5, we do have parentheses. So we're going to distribute to get rid of those parentheses. That gives us a 5m plus 25 is less than 5m plus 17. Okay? I cannot combine anything on either side, but I do have the same variable on both sides. So I'm going to subtract 5m minus 5m. My variables canceled on both sides. I'm left with 25 is less than 17. Is 25 less than 17? No! This guy has no solution. It doesn't work because this will never, ever, 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 ever be true. 25 is not less than 17. It's no good. Number 6, parentheses, distribute negative 8s plus 4 and 1 minus 8s. All right. Variables on both sides. Get rid of the one on the right. Plus 8s cancels. Plus 8s cancels. 1 is less than or equal to 4. Is 1 less than or equal to 4? Yes, 1 is less than 4. So this guy's true. So this is the first time we've seen one of these guys where it actually worked out true. 1 is less than 4, so the answer is not no solution. The answer is actually all real numbers. Everything. All real numbers. And if you really wanted a graph, the graph is going to be everything. Both sides, all directions, everything in between. Every real number is a possible answer. All decimals, all fractions, all whole numbers, positives, negatives, zeros, anything you can think of is a solution to that problem. All right. So now let's just take a look at some applications and we're done. Letter A here says, you want to buy some candy at the store. Okay. You want some gummy worms at $2 a pound. Okay, so we want worms are $2 times pounds. Because each pound is $2, okay? And 2 boxes of nerds, plus nerds. You want some gummy worms at $2 a pound and some 2 boxes of nerds at $1 each. Okay, so oopsie, oopsie, oopsie. They cost $1 and I'm buying 2 of them. It actually even says I'm buying 2 boxes of nerds. It doesn't say how much, like some random number of nerds. It actually says I'm buying 2 boxes of nerds at $1 each. Okay. How many gummy worms can you buy with the nerds if you only have $7 to spend? So I need my worms plus my nerds to be less than or equal to $7. So this is my verbal model. Worms plus nerds has to be less than $7 because I only have $7. I can't spend more than that, but I can spend up to 7. So now we just turn this into our little math problem. So 2, maybe W for worms instead of P for pounds, 2 times the amount of worms plus, now this guy is just a number. That's 2 times 1 plus $2 is less than or equal to 7. If we solve this guy, we got ourselves an answer. So we minus 2 on both sides. 2W, these cancel, is 5. Divide by 2, divide by 2. W is less than or equal to 2.5. So I can buy anything less than or equal to 2.5 pounds of worms and spend less than my $7. And it included a graph space here for us, so I guess we'll graph it. Why not? Remember that trick I showed? I think it was in the last lesson. I'm going to put just whole numbers. So 3, 2, 4. What am I doing? 4, 5, 2, 1. 2.5 is halfway right here. 2.5. I need a solid dot at 2.5, and I'm shading less than to the left. Okay. So my worms plus my nerds had to be less than $7. That's what it says. I want to buy worms. I want to buy nerds. How many worms can you blah, 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 if you only have $7 to spend? So worms were $2 a pound. So every pound was $2. Nerds, I'm only buying 2 boxes at $1 each. That verbal model changed into this inequality. We then solved, and we got the poundage of worms to be 2.5 pounds. So anything less than or equal to 2.5 pounds of worms, and I'd be less than $7. Letter B. On an elevator, there are a bunch of kids and an adult. All right, so kids plus adult. Each kid weighs 70 pounds, so 70 pounds times the number of kids, and the adult weighs a solid 200 pounds. Adult is 200. How many kids could be on the elevator before the 1,000-pound weight limit is reached? So I want the kids plus the adults. I don't want to be more than 1,000 pounds. If you're more than 1,000 pounds, the elevator is going to crash and you're going to die. So I want the kids plus the adult to be less than or equal to 1,000 pounds. For those who don't know, LBS is the abbreviation for pounds. So 1,000 pounds. So kids plus adults to be less than 1,000. 70 pounds for each kid plus $200 for the adult, or 200 pounds for the adult, is less than 1,000 pounds. So this is our verbal model. This sets us up for our inequality. So now watch. 70K, that's 70 pounds for each kid, plus the 200-pound adult is less than or equal to 1,000 pounds. Do you see how simple that was to set up? Now that we pulled the information, we made a verbal model, now the inequality is cake. And we solve. So we minus 200, minus 200, we get 70K is less than or equal to 800. Divide by 70, divide by 70. K is less than or equal to, I don't know, let's see. 800 divided by 70 equals, it says 11.42. So I could put a little more than 11 kids. So I'd want to put between 11 kids and less. So if I have less than this, I'm good. If I have more than this, I'm not good. So the answer here is like 11.42 kids is the maximum amount of kids you could put. So again, this is a decimal, so I'm going to put whole numbers around it. So I'm going to put 10, 11, I'll move it over one. Put 11, 12. 11, 12, 13, 10, 9. Put our point here, 11.42. That's almost 11.5. It's like right here in the middle. 11.42. We need a solid dot at that. And we're shading less than. So I could put 9 kids on, and the elevator's not going to crash. I could put 10 kids on. Elevator's not going to crash. I could put 11 kids on. Elevator's not going to crash. Once I get 11.42 kids, so like that 12th kid like starts to get on, he puts his foot on, that's when the elevator might crash because it has too much weight. Okay. Last problem for you to try. It says here legless can carry a 5-pound bow. Let's fix that typo while we're here. Can carry a 5-pound bow and a quiver of arrows. Each arrow weighs 0.3 pounds. What is the number of arrows legless could carry and still be carrying less than 14 pounds? Pause the video. Try the problem on your own. When you're ready to continue, hit play and we'll go through it together. Okay, so hopefully you did, and let's do it together. It says here, in fact, I'll change to green for Legolas. Legolas can carry a 5-pound bow. Okay, so he can carry his bow plus his quiver of arrows. And I remember reading through, we want all this stuff to be less than 14 pounds. So bow plus arrows, he wants to be less than 14 pounds. Because, I mean, he's light and he runs and he jumps and he doesn't want to carry a whole ton of weight. So his bow plus his arrows, he wants to be less than 14 pounds. Okay, his bow was 5 pounds. His arrows are 0.3 pounds each. Each arrow is that, which means that times the number of arrows. I'll put number of arrows. We want that to be less than 14 pounds. So, verbal model, with that verbal model. Whoa, nice M. Some alien M with 3 humps. And now we change it into our actual inequality. So we're going to take 5, we just don't need our labels, plus 0.3, sure, we'll still use A for arrows, less than 14, and we don't need the label. This is our inequality. Now we just solve that. Subtract 5 on both sides. 0.3a is less than 9. Divide by 0.3, divide by 0.3. A is less than 9 divide 0.3 equals 30. So Legolas could carry up to 30 arrows with him. Anything less than 30. He wants to be less than 14 pounds, so if he carries 30, he'll be at 14 pounds, and that's no good. He wants to be less than 14 pounds. So we got 30, and bigger, and bigger, and smaller would be 29, and then 28, and hollow dot, and less than. So this is the shade is the number of arrows he could carry and still be less than 14 pounds. He can carry less than 30 arrows. Not too bad. Not too bad at all. Last thing, how are inequalities different from equations? So now we've seen how to solve inequalities for a couple lessons. We've seen how to solve equations way back in chapter 3. How are those things similar or different? How are inequalities different from equations? Hopefully you said something like, equations typically only have one answer. Usually you get like x equals 3 or m equals 12. Inequalities usually have an infinite number of answers. So, I mean, equations you get like x equals 3, where you get one answer. Inequalities, if you get x is less than 3, every number less than 3 is an answer. So 2, 1, 0, all those negatives are answers. So that's one major difference. You might have said that equations, you don't require a graph when you solve them. Inequalities do. In all of our inequalities, we made a graph because it makes it easier to understand our answer. So inequalities require a graph. In fact, let me put this equation stuff here and inequality stuff under inequalities. So inequalities, you have this. Equations, you have that. The solving is pretty much the same. The one difference we saw is when you divide by a negative, or multiply or divide by a negative, you have to change the direction of the inequality. So those are some of the differences you should have noticed, hopefully. And homework. Homework comes from page 372, numbers 4 through 12 even, which is not that many questions. And then 17 and 29. Thank you for watching. This has been lesson 6.3. Bye-bye.